Hi, grade 10s. Mr. McLeod here. We're going to do a little bit more trigonometry, and we're going to try to apply the stuff that we learned already in trigonometry to some word problems. But first, we're going to talk about two terms that are really important to these types of problem in terms of how we measure angles. I don't know if you've ever been to Toronto and around the base of the CN Tower. This is my artistic rendering of the CN Tower. As you're walking towards the CN Tower and you're looking up at the top, the angle that your head has to, as your neck has to crane, gets larger and larger. And we're going to refer to this angle as the angle of elevation. So specifically, it's a measure of from the horizontal and then going up. So if you're looking up to the top of the CN Tower again, you can measure the angle from the horizontal and going up. Also in the CN Tower, I don't know if you know this, but you can go up to the top, and actually you can arrange to walk around the top, the round part of the CN Tower. And so if you have a friend up there, or if you're up there, then you could look down at somebody that's on the ground level, and we can measure that angle. So that angle, if we measure from the horizontal going down, is called the angle of depression. And it makes sense. If your angle of elevation, you're looking up, and the angle of depression, you're looking down. And the most important thing to remember is you're measuring from the horizontal going up, or from the horizontal going down. So that's important to understanding what the questions are saying. So let's look at an example. Okay, in our first example, Jamal is standing on the edge of an 80-meter high cliff overlooking the sea. He spots a boat at an angle of depression of 14 degrees. How far is the boat from the base of the cliff? Okay, first and most important thing is to try to draw the picture of what's happening. So I'm going to draw very quickly the cliff with Jamal on it and the boat out in the sea. Here we go. Okay, here's my picture of Jamal on the cliff, and he is looking down at the boat. And we know that the cliff is 80 meters high. So we can put in some of these measurements here. So we have 80 meters high. And we know that he's looking down at an angle of depression of 14 degrees. So again, we want to measure that from the horizontal. So from his eyeballs, his eyesight, line of sight is horizontal. Whoops, let me try that one again. Okay, so from his line of sight, which is horizontal, which kind of looks like this, and he's going to look down to the boat like this. So this angle of depression goes here from the horizontal going down, and this is 14 degrees. It's really tempting to put that angle of depression in here because it's actually inside the triangle, but resist that urge and always put it from the horizontal going down. And how far is the boat from the base of the cliff? So what are we trying to find? Well, we're trying to find this distance here along this horizontal distance here. Okay, so how does this 14 degrees help us? Well, we could subtract 14 from 90 and get this interior angle of this triangle. That's one option. We could extend this green line and make another green triangle where we know this vertical side would be the same uh, length as this vertical side here. Okay, we could do that. One option is really simple that I like is if we use, I don't know if you remember from the parallel line theorem of last year, that we have a Z pattern. So we have a horizontal line here, and we have a horizontal line here. And if we use the Z pattern, then we know that this interior angle is the same as that 14 degrees there. So we have 14 degrees here. Okay, and that's kind of a nice, easy option because we don't have to do any calculation, and we just use that Z pattern to find the angle inside this triangle here that we've already drawn. Okay, now all we have to do is use our trigonometry, our sine, cos, and tan ratios to find the length of this x. So what do we do first? We have to label the triangle. So we assume that the cliff forms a right angle with the sea. So our right angle is going to go here. And we know opposite that is the hypotenuse. This angle inside we can work with. So that's our angle, and opposite that is our opposite side. And then along the bottom here is adjacent side. Okay, and from SOHCAHTOA now we have to pick the correct ratio to use, sine, cos, or tan. And so we know the measure of the opposite side, and we want to find the measure of the adjacent side. So we want to use opposite and adjacent. And the only ratio that uses opposite and adjacent is tangent. So we write down the definition of tangent. Tan theta equals the opposite side over the adjacent side. We fill in what we know. The opposite side is 80. The adjacent side is the one we're trying to find. That's x. And the angle theta is 14 degrees. Okay, now we're trying to solve for a side. So what we do is we put this side over 1. Tangent 14 degrees is just some decimal number. It's probably 0 point some long decimal number. That's okay. Any number over 1 is the same as just that number. And now we can just cross multiply to solve for x. So we have x times tan 14. X times tan 14 degrees equals 80 times 1 is 80. And we want to get x by itself. So x times tan 14, we divide both sides by tan 14 degrees. And great. And hopefully by now you figured out how to punch in these trig calculations in your calculator. I'm just going to punch in 80 divided by tan 14 degrees, which is about 321. If we round it to the nearest meter. And we just write a concluding statement. The next example. Zebediah wants to measure the height of a tree. He stands 18 meters from the base of the tree and measures the angle of elevation at the top of the tree is 52 degrees, and his eye level is approximately 165 centimeters above the ground. Find the height of the tree. Okay, just like we did the last example, we want to draw a diagram, and I'll. Okay, here we go. So Zebediah is measuring the angle of elevation at the top of the tree. So we have to go from his line of sight, and again, horizontal from his line of sight. So this angle here, although it doesn't doesn't look like it the way I drew it, but we're going to call this 52 degrees. And using our trigonometry will give us the length of this side of the triangle. But of course, the tree is that's not the full height of the tree. That we have to also add this amount, and we're given that right here. So 165 centimeters is 1.65 meters, just to keep the units consistent. Okay, now we want to label the triangle. We have hypotenuse. This side will be the opposite side, opposite from our angle. So we'll call that x. And then we have the adjacent side down here. And we know that he is standing 18 meters from the tree, which gives us our adjacent side. So again, we want to find the opposite side, and we know the adjacent side is 18 meters, because that's given in the question. So opposite over adjacent, that's the tangent ratio. You'll notice that the tangent ratio is used a lot in these questions because it's really easy to assume that the horizontal has been measured and we're trying to find the vertical height of something. Although sometimes questions are set up so that we find the slanted height or the hypotenuse. which is approximately 23.04 meters. All right, so that gives us the length of that side of the triangle, but let's add the 165 to give us the full height. Okay, in this case, the full height of the tree is 24 meters, 24.69 meters, and we just write it there, a concluding statement. Doing this example makes me a little sad because things this year are so different. Um, One activity I love to do with my class is take them outside, and we actually do this experiment. We can measure the angle with kind of a protractor with a little string hanging down with a weight, and we actually do perform this experiment outside around Boulevard Lake. It's kind of a nice day. I'm gonna do one more example for you, just to show you that sometimes there's two triangles involved in some of these problems. So we have another cliff one. From the top of a 350-meter cliff, the angles of depression of two boats on the water are 26 degrees and 32 degrees. How far apart are the boats? So again, as always, draw your diagram. Okay, and we can draw our angles of depression. So remember that we always go from the horizontal, like this, and then down to the green boat first. And we can also look down to the red boat. All right, so we measure. All right, remember that the angles of depression are from the horizontal going down. So this smaller angle to the far boat is going to be 26 degrees. And this bigger angle to the red boat is going to be 32 degrees. And again, from the Z pattern, we can put 32 degrees here and 26 degrees here. We know that the cliff is 350 meters. Okay, and we're asked how far apart are the boats. So that's this distance. Okay, so unfortunately, our trigonomic ratios, the sine, cos, and tan, only work in right triangles. So we can't find this measure directly. So what else can we do? Well, if we could find the length of the horizontal side of the big triangle, and then we could find the horizontal side of the little triangle, and then if we subtract those two measures, then we'd be able to answer the question. So here we have to use two triangles. So we find this horizontal side of the big green triangle, and then this horizontal side of the red triangle. So let's call this this distance here, this red triangle, x, and then maybe I'll use y for this one. Okay, and again we're going to use the tan ratio because we have the opposite side over adjacent. So let's find x first. So okay, this distance x is about 560 meters. Next, let's find y in very similar way. Okay, so we got the horizontal side of the big triangle is 718 meters, and the horizontal side of the red triangle is 560. And then we can subtract them to find how far apart the two boats are. Okay, there's our answer. The two boats are 158 meters apart. All right, that's it for now. Good luck with this. We'll talk to you later.